So our objective of today's class is functional and non-functional requirement understanding, and um, how to develop the functional architecture we'll learn today. And if we have a little bit more time, then Sabina will show how to do the functional architecture in enterprise architect. So let's see how far we can go. Okay. So, in our requirement engineering, you have learned functional and non-functional requirements. So there, I didn't actually describe everything, what is functional and what is non-functional requirements. So before going to the functional and non-functional requirements, we're supposed to know what is a function. So I think it's quite straightforward, but for model-based systems engineering, we're supposed to know this one quite explicitly because it has a good use cases during the architecture development. So function is, according to Inclusive, a function is a characteristic task, action, or activity that must be performed to achieve a desired outcome. So that is that we all know. I think a function, normally in a sentence, when you will see a verb, normally express the function. And functional requirement generally depends on particular functions, whereas non-functional requirements generally has an effect on the various functions. So functional requirements and non-functional requirements. Is it quite clear from the definition, or should I give a little bit more overview? Okay. So functional requirements define what the system must do or perform. So I think in the first class we are talking about aircraft design. So one flying vehicle, and what could be the function of a flying vehicle? Yes, yeah, one function. Then anyone else? Yeah, another functions. Another functions. This is little bit another direction. It is not exactly the whole aircraft function. So this is maybe a class of function, but we are first try to define what are the main functions of the aircraft. So let's say carry goods as well from point A to point B. Yeah, so these are the functions. And when we are talking about the non-functional requirements, then it is most of the time qualitative. It is not quantitative. So let's say the aircraft supposed to looks good. So this is a non-functional. So looking good, like, it is undefinable. You cannot really define that something is good and something is bad. So you cannot quantify. You could define, but you cannot quantify that. So when something is non-functional, it somehow explicitly express the functions. So it helps to understand the functions. So those are the non-functional requirements. But don't think like only the functional requirements is important in model-based systems engineering. Both functional and non-functional, both are really important because you cannot really deliver a product or manufacture a product or design a product without understanding the non-functional requirements as well. So both are really important. But the goal of today's lecture is to understand the functional requirements. And then if we understand the functional requirements, then we can design the functional architecture. Okay, then non-functional, also known as quality requirements, as I have told, generally more difficult to express in measurable way. So you cannot really measure the non-functional requirements. Any question here? Okay. Then functional requirements characteristics define what the system should do, be action-oriented, describe tasks and activities, are associated with the transformation of input and output. So these are the characteristics of functional requirements. You will get more idea on that in next slide. And non-functional requirements are, as I have told you, it's a qualitative thing. Like most of the time, this is beautifying the functions or helps to understand the functions more explicitly. So can be subjective, relative, and interacting. Describe how well the system must operate. Then associate with the entire system. So non-functional requirement mostly it describe the whole system's function. Whole related with the whole system. So then how you gonna know the non-functional requirements? Mostly it describe, you see the understandability, usability, modifiability, then security, simplicity, clarity, then user friendliness, robustness. So these are the things, and many other things, let's say performance, efficiency. So those are the things. Of course, the cost. What do you think? Like cost is functional or non-functional? No, this is non-functional because it does not affect the function of the aircraft. Let's say, to be more clarified, let's say one aircraft is cheap and another aircraft is expensive. So the aircraft function, we understand that it's supposed to, let's say, carry goods or passenger from point A to point B. So if the cheap one is functioning in the same way, you see the cost does not affect the functions, but yeah, no, it is not in this way. But you see, let's say when you have less expensive things, so maybe you cannot justify the security or safety because safety is the issue, right? So let's say we do not like the Chinese product because why? They are functioning, but they are not durable. So durability is not a function; it's a qualitative. So it's not quantitative. So very simple. Like when you see something is quantitative, so most of the cases this is related to function, and when it is qualitative, then it's non-functional requirements or non-function. And there is some good taxonomy, like the classification. I found this quite interesting. It's also from a book. So in the design concern, what are the non-functionality we are coming across? So this is compatibility and consciousness, consistency, interoperability. So those are the things. Adaptation concerns, adaptability, those are the things. Viability concern, accuracy, efficiency, and those are the things. Then sustainability concern, availability, maintainability. So more or less, when you come across to the non-functional requirements, those are the areas it's supposed to cover mostly. But of course, when you are designing a software, maybe in some cases, this is really hard to understand, like, because those are the thing I think easy to understand when you are designing something physical. Let's say, a car or a motorbike. But I think for software designing, these parts are a little bit difficult to identify. It's my cases, but maybe it's not in your case. Okay. So there are also some classification. This is only for main purpose. I just put here. So you can have a look when you wanted to have deeper view on non-functional requirements. Just go through with this. So this is a little bit descriptive thing what I discussed before. Okay, so there are Somerville's non-functional classification schema. This is another way how another researcher described this product requirement. So he divided the non-functional requirements in three ways. So product requirements, organizational requirements, and external requirements. Yeah, but this is very, I think, top view. It's not really so interesting, and it's in terms of application, this is very vague, I would say. But for learning purpose, you can go through with this. Okay, so we have known the functions and non functions and functional requirements and non-functional requirements. Now we step into the functional modeling. So functional modeling is a process of building an abstract model for a product based on its functionality. Functional modeling is a proven and useful method that enhances system designers or architects' understanding and initiate enhanced communication for complex product development. So this is a definition so far. And this is honestly speaking very confusing. It was very confusing, and I took a long time to understand this, even though Sabina and me had several meetings with this since few years. So it has actually many names. So this is the first thing. If you see somewhere or some articles that are describing functional design, don't be confused that this is the thing what you are looking for. Maybe some publication or books are describing functional architecture, functional design, functional decomposition. So they are like there is no one name. But I actually prefer it is functional architecture because we are developing architecture. If you can remember Sabina's lecture with enterprise architect, there she was defined the architecture. So what is the architecture? So I think functional architecture is it's more acceptable to me. Okay, function in mathematics. So normally it's very simple way I try to describe. Let's say f of x, and you have a rule. So 2x squared plus 1. So that will give the output. So when you are trying to design the function or functional architecture, you're supposed to think in this direction. So let's say what you are importing into your system, and that actually gives a output. So this is somehow the right way of visualize the functions. So you will have input, and in the process you will have many functions, and you have to see what are the inputs are needed to deploy the function. So this is the understanding we need to design the function, because like only through the system requirements it is hard for the designer to deploy the system's architecture. It is not really possible. So that's why what we have to do, we have to do several steps. Let's say we are doing requirements engineering, then we are doing functional architecture, then or functional design, then we are doing uh, logical architecture, then we are doing the physical architecture. So these are the, if you consider the waterfall model, so these are the four steps normally we are following when we are designing some product. So similarly, when you design the functions, you see, if you understand the functions, it is easier for you to understand the logical architecture, because the logical architecture, I think we need to take a class on that, the logical and physical architecture, but you will get some essence today, because also functional architecture is related with your physical architecture, because to verify the functions, you're supposed to align your functions with your physical architecture. In the next slide, you will find those information as well. So normally in the functional design, you will see we'll have input, and normally the most common input elements are materials, information, and energy. And there you will have several functions, and those functions you have to somehow have an effect on another functions. So these are the way you will design your functions, and you will have your desired outcome. So there you will also get the materials, information, and energy. But when you're gonna design the function, you will see it's not always the case that materials, information, energy is the input or output, because something comes different, and you cannot really define that what should be that particular input or output elements is that materials, information, and energy. But these are the common things. So I will describe that in, I think, almost in the last phase, that materials, information, and energy is not only the input. There are some others as well. Okay. So functional modeling perspective. So when we are designing a function, we're supposed to consider that the function has a state, and the state is changing. So this you have to consider, and there are some explanation I gave from a book. There they describe the welding robot. They consider the welding robot as an example. So state change, representation of the state of a system based on its input, process, and output. So energy, material, and information. The welding robot changed the state of metal sheet operands from loose to weld, and the state of the welding tongues change from open to close. So you see, if you consider this particular part, so the welding machine has changing its state. It is doing something. So if something is static, you can easily say that this is not functioning. So let's say if you are in front of the lift and the lift is not functioning, how you understand? You press the button and see nothing is going on. So if something is functioning, it's supposed to change its state from one to B, or from A to B. Use cases. So the second perspective, representation of different cases of applying the technical system is typically associated with the interaction of stakeholders or another technical system with the technical system under development. So this is functional modeling also related with the use cases. I think you also heard about or maybe already seen something about the use case model in enterprise architect or any other system type modeling language. So never mind. So you can also express the functional modeling with use cases. So a use cases is like Lavina, you correct me if I am mistaken. Uh, let's say let's say I don't know. You have a function of x, you know. So this is a function, and this function is supposed to drive by a what do you call this actor. So you need an actor. So let's say I don't know. Actor could be like this, and like you understand the use cases will be here. So let's consider the x for aircraft. So what could be the use case of a aircraft? It is, you will see it is almost similar to the function. So on one use case of of the aircraft, or maybe you can say a automobile or a car. What could be the use case? Sorry? Yeah, transporting people to transport, I don't know, like XYZ whatsoever. And you need a actor, like uh, who gonna do the use case, right? So and you need a relation. So, and uh, let's say if we have and this is maybe like this use case is for whom? It's for maybe for a stakeholder, right? So who could be the stakeholder? I don't know. Could be the I don't know. It could be the let's say a transport company, maybe. Um, so similarly, you could put more stakeholders, and you see how it is related with different use cases, and somehow those use cases are related with the function of your product or function of your system. And this use case diagram you will see in CSML. This is also a class of CSML diagram. How many diagrams in CSML, Sabina? 9. Yeah. So this is one of them. Then it has activity diagram, then state machine diagram. So there are different diagrams. So the use case is also part of the functions. Okay, and subsystem allocation. So through the subsystem, like when you are defining your main functions, then it is not really clear like how you gonna divide it your subsystems. So functions also help to understand or define what could be the subsystems and how it could be. I will show in the next slide. And the stakeholder allocation, as I have already shown. So let's say here you will understand for whom you are doing these functions. So these are the characteristics or the perspective of functional modeling, and there is a the explanation also there. So, okay, so now is function trajectory. So where from the functional architecture actually coming in? If we consider the PLC, product life cycle, it's normally the product planning, product development, product assembly and test. So this, sorry, production and production assembly test, marketing, maintenance, recycle, and disposal. And here, this is actually the product development phase. And when we are doing the conceptualizing or conceptual design of the product, there we are doing, this is requirement design. So somehow this is the requirement engineering because it has also some steps how you gonna define your requirements. Then functional design and modeling. So this is the part what we are doing, and it has different name. So I just try to graphically represent where from the functional architecture is coming. And then we are normally doing the physical. And before that, as I have told you, we also do here logical architecture as well. So this is somehow how we design the concept of the product. Okay, and these are different part. Not this part is not important. So therefrom we found functional design or functional architecture. So this is one of our research part. Actually, currently this publication is stopped because it's almost in the end, but we didn't write it fully. So in traditional approach, transformation of functions are normally unknown. How? Because what is behind the functions? We normally, when we are bringing the functions from requirements, when we have the requirements engineering, then we are getting the functional requirements and non-functional requirements. But how these functions are coming, it's mostly undefined. So Professor Simon actually was asking that before going for the functional design, we're supposed to identify or qualify that function. Is this function is the real function what we are trying to have for our product development? So therefore, in the proposed approach, what we are seeing, like we design the function and then we will take off the curtain and there we will get as an output our real function, and then we will assembly the function. It is similar type of thing like when you are manufacturing a product from raw materials to end product. So you are designing, then you are manufacturing, and manufacturing not the whole product. So in the manufacturing plant, if we consider the aircraft, let's say, so most of the cases, the wing is produced in one part of the production plant, then the body is produced in another part of the production plant. Then the engines also produced or getting from suppliers. And in the assembly section, they assemble everything and you will have your finished product. But before that, before having your finished product, they have to also assemble the electrical system, then they paint it, and then you get your final product. So similarly, in functional design approach, we understand and design the functions, what is needed, and then as output we'll get the function. Then we are doing this functional modeling or functional architecture. So this is the proposed approach, and how we gonna do this? we're gonna do this in this way. So in the functional function engineering, we understand what are the actions, object, objective, and subject for the functions. Then we design the functions and we get our output. So this is the function. And then we are doing the functional modeling or functional architecture. So functions are abstract. They merely specify which action should be taken on which object by which actor and which purposes. This is also another way of understanding. So here you could see that two birds are flying. So birds are flying in the sky. Are you agree with me this proposition that this is also some kind of function is going on here? But do you think this is the explicit function I try to describe with a sentence? Rather than doing a model, I try to describe by writing. It is similar to mathematics. Yeah.
So the model is supposed to be a I would take only one, for example, the first step, that flying is that.
What is the function here?
Flying is that.
Yeah, so flying is the function. And not in the sky is not the function. It is somehow describing that where the bird is flying. It's flying in the sky, right? So, but in the graphical presentation, do you think that the birds are flying in the sky? No. So we should bring the sky, right? And you see, but according to this proposition, this is not really the right sentence. So I think birds are flying in the sky with their wings. So birds are flying. It is not really. It is quite explicit for us. The birds are flying with their wings. That is obvious, right? But when you are designing a system, then everything's supposed to be specified because this is a common sense. But when you are designing, let's say, a mechanical system, and if the wording, let's say, like you are telling that some functions are there, but how the functions are taking place is not explicit in your design, then I think, let's say, the electrical designer or electrical engineer will not understand it correctly. So maybe he could design something else, what is not maybe the desired outcome. And you see, for what they are, so the functions are also supposed to have a objective. So we are not designing the function without having any purposes. It's supposed to describe a purpose. So what's the purposes? To reach their nest or to reach their home. So when you're gonna design something from enterprise architect or SysML or UML language, your system supposed to describe something like this, very explicit. And the functional, when we are designing the functions, and if you try to do some kind of design based on your functions, like what is needed to explicitly describe your functions, then before going to the functional architecture, it's always gives you a explicit understanding. Is there any question here? Or is it really understandable? Feel free. We can discuss this thing more as well. No question? Okay. So now we see what is functional allocation. So I think everybody of you use the ATM machine, right? Where from you get the money and or deposit the money. So the function they describe in a way like what you do. Just visualize when you are in the bank, you insert your card, and then what what are the functions the system first done, first do? Verify that is it the right person or not. And how they verify? They ask like, what is the PIN of your card? Then there are the functions, and based on your requirement, what you're gonna do if you wanted to deposit some funds, then you follow those, right? And when somebody wants to withdraw the cash, then these are the functions and sub functions. Then also something gonna be done maybe, but I never did it with ATM. Transfer funds. I don't think so. People are convenient with this. And yeah, this is I think very common. Sometimes people want to check their account. So this is the way how you divided, your main function to sub-function level. And what it actually does, it helps you to understand your functions, like what are the things you need to do to deploy your system. So with Sabina and me was discussing like um, with those diagrams, what we actually wanted to achieve. Um, it's like in in terms of understanding, this is um, I would say this is in another way. This actually develop a common understanding. So you understand the thing, and if somebody you see like we are not the designer of ATM, right? But we understand how the things is thing, or ATM machine is working. We understand this, right? So this is really very important when you are designing. So we normally try to deploy this clear understanding or explicit understanding or rational understanding. Okay, so the functional architecture, don't be confused. As I have told you, previous one was functional allocation. So why I'm telling different things, you will see, because we have to do a process to design the functions. So first one is function design based on action, activity, object, and objective. Then we will have our clear functions, and those functions then in the previous slide, sorry, in the previous slide you have seen those we need to do kind of top-down approach. We have to segregate what are the function and who is under whom. So then you have a clear picture of your system. Then you will go for the functional architecture. And this is kind of definition, but rather describing this, I will describe the functional architecture in another slide that would be more easier to understand. So types of functional architecture. You can describe your function through list. You can describe your function through functional tree. You know how we are doing the functional architecture. You see, this author is telling functional function tree. So, and previously what we have learned, this is functional allocation. So, from top to bottom, a main function to sub functions. And then this one we are calling functional network, functional architecture, and he is telling functional function network. So how the functions are related one to another, and what are the input and output of each function. It has been done in this way. And here he shows how the complexity increase during the design phase when you are, let's say, when you list your all the functions, then it's quite easier. And when it goes to the functional network, it's a little bit complicated. But I personally think a designer supposed to perform all the three to have a very clear understanding of a function. It's not like if somebody is doing only the functional listing, is the design is finished. It is not like this. I personally think it is better because the architect or the system architect supposed to have a clear understanding on his design. Therefore, it is better to design in this way. Okay, this from another author is telling that create a simple functionality for operational concept. So from the operational perspective, you're supposed to um, describe your functions and allocate them and complete function and data models. So this is more or less cover both what do you call this software development and mechatronics development. Then trace input output requirements for function and item. So these are the three steps. But it's a little bit complicated to understand. So I I think this is the better way. If you want to create explicit functional architecture, so this is supposed to be the process. First, we design the function based on subject, action, object, objective. And I think also the state change is also necessary because OPM, have you heard maybe this language? Object, I forgot the full abbreviation. Sabina, do you remember OPM full abbreviation? Object, yeah, object process model. Yeah, exactly. Thank you. So this object processing language similar to SysML. They are also ISO certified. Their state is very important because this in this design function is the seed. Like it's quite interesting, and it is also free if you search OPM and I forgot the website name, but I think you will find it in Google. They also have an online possibility to design the thing and download and install in your computer. So their function is used as the seed. How, let's say, if we consider to grow a plant, what we normally do. Have you done anything with gardening? Anyone? No? So normally what we do, we buy some seeds and we plant those seeds and it grows as a small plant and it grows and then it gives the, what do you call, the output. Like, let's say if you wanted to have capsicum, then you buy the capsicum seeds and plant it, grow the plant, and it will, bloom someday, and then it will produce the fruits. In OPM, it is similar to that. So he consider what is the main function, and then you design what is the next function and what is the next function. So it grows like a trees, and it's like a nice method I found, but yeah, but it is not so useful for our purposes because function is not only the case in terms of design, because there are some other things we need to understand in a design. So in some parts, this approach, as especially for functional design, I found it very useful. But the other part, this is my personal opinion, but for the other part of the design, let's say logical architecture design or physical architecture design, it's not so useful. So then after having done your functional design, you will do your functional allocation, the top-down approach, and then you will do your functional architecture. And how you will do your functional architecture, I will show you in a second. And when you are done with this, then you will evaluate your functional architecture through your physical architecture. So when you will have your physical architecture, you will make the comparison. And that one I will also show you in the next slide. So before going to the evaluation, first we have to understand what could be a physical architecture. So here is a physical architecture of a elevator. So you see passenger interface compartment, what are the subcomponents, then elevator control components, you need hardware and software, then elevator cars compartment, like where we normally get in. So what are the components? It's described here. And of course, this is a common thing for every physical object, even though for the software object, you also need to have the maintenance and service. So those are the things like how he described the physical architecture. And this is actually the functional and physical architecture matrix. So these are the functions. We bring the uh, functions for a aircraft, and this is the physical architecture of a aircraft. So aircraft, airframe, engine, communication, navigation system, and fire control. And here is the functions: pre-flight, check, flight, load, taxi, takeoff. But I would say those are not so explicit. I think some more words would be nice to have clear functional understanding. And how those are related with those, this are being check marked. So these are the thing like how you should evaluate your functional architecture when you will have your physical architecture. Okay. So now this is the thing what we wanted to do. This is the architecture, functional architecture of hair dryer. So if you haven't forget the hair dryer. So first function is if we wanted to dry the hair. So in the output, what we are expecting, we're expecting hot air, right? And it does not comes automatically, right? So from the functional view, if you see as an input, what we are having here, draw air. So convert energy to flow of air. So here you see from the functional point of view, and in the physical view, what could be the component that could serve this function? Sorry? And yes. So you see, if you understand this, then your physical architecture is really easier, right? So then the second one, apply heat. So you are bringing ambient air, and from there, this air is not hot. So normally it is not hot, and apply heat is the second function. And for applying heat, what you need? You need energy, right? And this is also input and convert energy to heat. So this is you need another component that could convert the energy to heat. And what could be here? What could be the physical component here? We could have a electric coil, right? So you see, then We are having hot air here, but this is not our expected hot air, right? Because we need something controlled. If it is uncontrolled, then it will, what do you call the, in thermodynamics, there is a, I forgot the specific name, like the limit of disorder, whatsoever, it's not so important. So we need to regulate the heat, okay? And who's gonna regulate the heat? The system, right? But the system needs some input. And you see, previously I told the inputs are not always the energy, materials, and information. So you need some other things. So you see, you need people. So yeah, people is kind of materials. It could be kind of energy because we build up with molecules. If you destroy us, you will get the energy for sure equal to mc square. But we do not want to understand from the molecular level. Therefore, you see, we need people here. Um, but of course, if if you have some kind of autonomous system which is connected with the user brain, then maybe you do not need the machine could regulate the heat as per the desire of the user. But I think this is very hypothetical thinking. So normally this is a manual hair dryer, and you need a user who gonna select how much heat he needs. Okay. Then we are getting the hot air again, this hot air, but this one is controlled. Regulate hot air, and this regulate hot air, like now we have our that this regulate hot air produce hot air, and then as the output we are getting expected hot air, and then we have to channel it. And because if you cut from here immediately after production of hot air, then the flow will be very distorted. So you cannot, dry a specific place. So you need a good tunnel who could channel the hot air, and as an output, you are getting controlled hot air. So this could be the expected functional architecture for a hair dryer. Oh, it's almost finished. Now we are having another half an hour, right? So yeah, so I think this is the last slide. The common mistake in functional design. So when we are designing the functions, we try to forget. Normally, we forget the external systems and their function. We try to include everything, and that is not really good. So you have to be very careful when you are designing your functions. Be within the system boundary. Then a wrong name of the functions, but I think in our approach, if you follow the process, function design, functional allocation, then functional architecture. So it will somehow has a link from your previous part. So it won't be bad, or the wrong name wouldn't be possible in this process. But normally people are starting functional architecture without doing those previous steps, let's say functional design and functional allocation. Okay, then creating a decomposition of function that is not a partition of the function. So you have to also identify what are the partition between your system level to subsystem levels. Other than it would be also difficult. You could, mixing the sub-function with your function. Then include var phrase. This is, I think, normally not the mistakes, but this, though it's from a book, maybe this is right. But I think without var, you cannot make your functions. Then creating output from thin air. So sometimes it means like you are designing some functions, but it seems like, without having anything, the functions has an outcome. So that is that you have to be very careful. The common mistake is to define a function that monitors the system status, but that does not receive inputs about the functioning or lack of functioning of other parts of the system. So yeah, if you do the function design, then I would say this part also possibly, you could obsolete this part as well if you do the function design first before going to the functional architecture. So those are the references. Yeah, and this is the end of functional architecture. And if you have any question, we could, go through.